Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So let's continue our journey with quadratic function and quadratic equation. Function, remember, is when x is anything with a, b and c fixed, and the equation is when we have the same polynomial of second degree and we want to find its solution when this polynomial is equal 0. So this is kind of for any x, and this we want to find the x for the same thing when it becomes 0. Alright, we already solved b and c separate. Now generic case when nothing of this is 0. A, b and c are all not 0. And let's talk first about completing to the full square. Completing this polynomial to the full square, and let's start with something like example. 2x plus 3, and this would be y over x. And a, of course, in this case is 1, whatever here. B is, of course, 2, whatever here. And c, of course, 3, whatever here. Okay, and completing to the full square means that I want to do a trick with a plus b squared. Remember, a plus b squared, but a, b taken, let's say, u plus v squared. And pause, you remember. If you don't remember, you have to visit basic first lecture or first problem in this playlist, and you will of course write that it is this, this and this. And this is a trick. So I have this, I have this. I have something here, so I have u. You already have, and in this case I already have 2. So we have to start making transformation. We have full square here. It's very good. We have full square here, we have 2. Very nice. And we have this, x. And so we have to change nothing, so we have to multiply by 1. So far I changed absolutely nothing. This is this, and this is this, but I presented it as 1. Because this is 1, I write here 1 squared, right? And because I added 1 squared, I have to subtract 1 squared. So all I did, I presented this in this shape, and then I added 1, I subtracted 1, and I have plus 3, because I have to have it the same. So y over x equal x squared plus 2x 1 plus 1, put them together, minus 1 plus 3. X plus 1 squared plus 2. And this is the form of my, I changed nothing, I just changed the presentation. So I started with this function. This is absolutely the same function, but presentation is very different. And right away, I can say that this is a parabola, because the minimum when x equal minus 1, this is the minimum of parabola. Parabola is opens up because it's always, and the parabola is always positive. So I straight away can say this is x, this is y. When x plus 1 is 0, meaning x equal minus 1, x plus 1, 0, meaning x equal minus 1, this goes to the side. This is the minimum value of the whole function, because this becomes 0 and all we have is 2. So we have a parabola that opens up. That's it. This is our graph. This is our symmetry. The symmetry axis goes when x equals -1. And we solve this completing the whole thing to the full square. And we have no solutions. By the way, if you calculate b squared, it would be 4 minus 4ac minus 4 multiplied by 3. 4 minus 12 is -8. There is no square root of this. There is no solutions. All right. So let's take the same as a different a little bit polynomial. It's polynomial of second degree. This is polynomial. I should write this in the very beginning. So this is a polynomial. Polynomial. So, and I want now to write function. This is a second degree quadratic function, right? And I want to do it with those numbers. Fantastic. Let's again use the same trick. We have y, x equal x squared, and it's already squared. Okay, then there is minus, so the formula that I will be using is u minus v squared, and it's pretty much the same, right? Pretty much the same, plus v squared. So I have minus, I keep it minus. I have 2, I am happy. I have u, this thing not squared stays as this, and as we know, I put 1. And if I put 1, I have to have it 1 here and add 1 here. So this, and this would be my together, because 1 squared and 1 squared is the same. X squared minus 2x plus 1 in the bracket, and here would be 3 minus, plus 2. And I now have x minus 1 squared, because this is exactly a full square, and this whole method is called completing to the full square. X minus 1 squared plus 2. I did something wrong. I just didn't want to put here. I put here minus. And this would become -4. That was my intention. I changed and my bad, but it's -4. And this will become this. Because the case when this is plus and there are no solution, we just discussed. And here I have this. And what I have here, I have quadratic function. When x becomes very big, this will become positive huge number. So this parabola opens up. And but the minimum, of course, when this thing is minimal, because it only adds positive contribution. So when it's minimum, x minus 1 should be 0 and x equal 1. So this is a minimum. So the graph becomes like this. And x equal 1. And this is minimum. And of course I can solve the whole thing when this thing equals 0. Let's say x minus 1 squared minus 4 equals 0. Now, I started with the polynomial. I have the function. Now I'm solving equation with the same polynomial. And this is all the same. And so now I'm solving quadratic equation. And of course I can solve it like this. And I could solve this like this. Absolutely. But this is the simplest way to solve it. X minus 1 squared equal 4. X minus 1 equal plus minus 2. X1 equals 2 plus 1. And x2 equals 2 minus 2 plus 1, it would be minus 1, so this is 3, this is minus 1, and we have this 0, this 0, parabola is open up, so it looks something like that. This is a minimum case, this is, I wrote a little bit, well, forgive me. 3 minus 1 is 2, 1 minus minus 1 is 2, so this distance equals this distance, this is axis of symmetry, and we build this thing, completing this polynomial to the full square. And this allowed us pretty much to solve it in the most generic case without restoring to this formula. Of course, it's a little bit complicated and cumbersome, and probably your teacher will not like it, and probably, it's much easier to solve it simply using the formula. We have x squared, what it was, minus 2x minus 3 equals 0 if I am not mistaken. And solution was x1 equal minus 1 and x2 equal 1. So if it's minus 1, it becomes 1, minus becomes 2, minus 3, 0 becomes 0. So x minus 1 indeed is solution. We validate it. Let's validate it 1. 1 squared becomes 1, minus something wrong, right? Something x2 equal 1, that becomes 1, minus 2 multiplied by 1, oh, it's 3, sorry, 1 is not solution, solution is 3. I already wiped it out and already forgot. So this all, we have to substitute 3 here. It becomes 3 squared minus 2 multiplied by 3 minus 3 equal, and 3 squared is 9, minus 6 minus 3 equals 0. So yes, these two are solution of this function, of this quadratic equation. So this is good. So I wipe it out, so x1 equals minus 1, x2 equals 3, exactly like I did last time. Now the last thing I want to do here, before letting you digest and try with your quadratic equations, with quadratic equations from your textbook, with quadratic equations that you can invent yourself, I want to solve this x1, 2 equals 2a, 2 over 1, minus b, b is minus 2, b is minus 2, b is minus 2 would be minus 2 would be 2, plus minus 2 squared, b squared, right? It would be 4, minus 4, a, it's 1, and c is minus 3. And it becomes x1, 2 equals 2, 2 plus minus 4, 4 multiplied by 3, minus would be plus 12, and this becomes x1, 2 equals 2 plus minus square root of 16. You know what square root of 16 is, of course. It is 4, 2 plus minus 4 over 2, x1 equals 2 plus 4 over 2 equals 6 over 2 equals 3. Oh, we have this. Very good. And if we put here minus 4 over 2, we will have minus 2 over 2, we will have minus 1. Fantastic. So, when you're given this thing, like what you have right now, what do? It's totally up to you. Everything is valid and you basically have to be confident what to do. I like this. This is a standard way with any equation. All you have to check as discriminant is positive. But sometimes you make an error, you plug the number, it doesn't work because you found some solutions and you remember how I validated them. You always have to validate them. and they don't validate, that means you made a typo, then you can try to complete to the full square. And of course also you have to listen to what they want from you. Because one thing you free studying, and one thing you do it for your analysis and for your understanding, and you have freedom to choose, and another you have a teacher that wants you to do this and this only way, and it is do complete to the full square, do a factoring out, and you do something else and you receive negative mark and or drop some points, and you don't want this. So listen what your teacher wants, but in your toolbox have this method, imagine how you draw the graph, imagine that graph is always a parabola, parabola opens up, parabola opens down, this is determined by this sign. If it's positive, in this case it's 1, then it's up. If it's negative, it will go down, and then go from there. Remember that the parabola is a symmetrical curve. Remember that if x corresponds to this axis of symmetry, it is an apex. It's always apex. It may be minimum or it may be maximum. This is positive a, this is negative a, and so on. So the more you know from different angles, the more helpful it is for you to solve the problem and get good points. But besides those points in physics, we're not looking here for points, we're looking for knowledge and understanding, because we will be using those parabolas a lot in my problems, and we already use them a lot in kinematics, one-dimensional. Anyways, subscribe if you liked, bell, don't to miss, like if you liked, question if you have, problem if you wish, and I see you next time. Thank you.